This is the task for the Mechanical Engineering CAD National Competition. This one is the 6 and 4-legged insect robot. So I'm just going to go down onto the first page. The task is the Mechanical Design Challenge. You'll be given 6 hours and you'll be given prints of the national task, which is what we're looking at here, the 6-legged insect robot animation video, and a folder that has all the data files that you need in there. So there's a bit of background knowledge here which goes through how the insect robot would walk. So the 6-legged robot walking in a straight line is based on the triangle gait principle. Usually the 6 feet can't move forward at the same time, but the 3 pairs of legs are divided into 2 groups, which you can see here. You've got red and blue, of triangular frame structure which can move alternately. The foot on the front and rear, on the left and the middle on the right sides as a group. So down here you've got A, C and E. And then the opposing ones, which are B, D and F, which are seen in blue. One of them relying on the leg paddling support and swing robot body alternately. Figure 1 shows BDF for swinging leg and ACE for the support leg. In this test, the gap between support and swing is not obvious due to the application of crank link rod mechanism. You're asked to complete the following tasks. Assemble the 6-legged robot and find out the movement interference part and improve it. Redesign the body cover sheet metal and build a new 6-legged robot. Use of existing parts to build a 4-foot insect robot. So we'll go through those. Task 1, you need to review the given animation, which is this one just here. Which basically just shows you how this walks. And then assemble the 6-legged insect robot. This figure down here presents how the leg, link, crank, motor and gearbox are assembled, so you can see that in here. All necessary parts and sub-assemblies are included in the data files. The missing standard connectors are selected by yourself. Please note that the 6 legs are all the same. You then have this clash down here. So task B is to revise one leg dimension to eliminate the moving collision shown just here. All other geometry cannot be changed, and then you need to print out the revised leg part drawing. So the output for task 1 is to produce a 6-legged robot's working principle of animation video, so essentially reproduce this, ensuring that the feet aren't clashing. You also need to show the cover shell gradually disappearing, then seeing the internal drive system mechanism. And you also need to produce and print an A4 sheet of robot leg part drawing, so the modified part. Task 2, you'll be required to redesign the sheet metal cover original part according to the dimensions shown down here in figure 3. Any missing sizes are decided by the competitor. Print the part drawing on an A3 sheet, and please ensure the redesigned flat pattern size, length, width is the same as the original. Tolerance of plus or minus 0.5 to 1 mil. So here's the flat pattern size, so the length and width is shown there. Part B, create a new sheet metal plate to assemble a cover assembly welding drawing. So this put down here. A3 sheet again, as figure 4, including bill of materials, weld annotation and an isometric shader view. Produce a photo rendered image of the complete 6-legged robot with the new cover, and make sure it's the image of the complete 6-legged robot, not just the cover, and display this one instead of the original. You then have the outputs again down here, so print top cover part, redesign 2D drawing on an A3 sheet, print cover sub-assembly welding drawing on an A3 sheet, and save a photo rendered image of the 6-legged robot assembly with new cover. Task 3. Maximise the use of existing parts and sub-assemblies of the 6-legged insect robot to build a 4-foot insect robot. You can't change the body frame structure, and only one set of motor and spur gear group is needed. The task 2 design cover welding sub-assembly must be used, so the new one. The front leg of left side and the rear leg of right keep in the same place, while the front 2 legs have reverse pace. Part B, produce a 4-foot insect robot exploded and assembly animation. Make sure it's an AVI format, and it's given you a time here, so make sure your video is 25 seconds long, not 24 and a half, not 26, but 25 seconds. Ensure to show every part, component exploding and then assembling. Create a 4-foot insect robot final assembly drawing with balloon and bill of materials on an A3 sheet. Produce an animation of the final complete assembly. This must include the following: the camera moving around the machine around 360 degrees. It shows the four legs mechanism from side and top view, showing at least one full rotation of the crank. Show the spur gears functioning, and show the motor holder is fixed. You then also need to produce a photo rendered image of the final complete 4-foot insect robot assembly. I suggest you make it the same as a 6-foot. So task 3, the output will be to save the exploded and assembling animation, print the final assembly drawing on A3, produce and save final complete assembly animation video, and save a rendered image of the 4-foot robot final assembly. Use of the computer is allowed for the complete duration of the competition, and the notes here are that the quality of the rendered images and videos is to be selected by the competitor, but all rendering must be completed before the end of the competition time. Videos must play through Windows Media Player on the computers provided. And please save all final rendered images and animations on the desktop. So here's your marking. Fulfillment of the design brief, you get 11 marks for that, so that'll be completing everything here. The physical simulation, you get 7 marks, so that's the animation. The exploded view, again 5 marks. And photo rendering, 2 marks. So you can see you need to spend most of your time on the fulfillment of the design brief. So that will be ensuring the collision doesn't happen anymore and taking it into a 4-legged robot as well. And then you get quite a lot of points here for the physical simulation animation, so it's worth spending some time on that. And again, 5 marks is a lot for the exploded view. And the photo rendering is 2 marks, so maybe not spend as much time on that, but photo rendering is quite quick, and we go through that in the selective task. So that is the task. It's quite a big one, so make sure you read through it carefully and watch the video a couple of times before you start your 6 hours.